Today we're going to be talking about how to use the greatest common factor and least common multiple in realistic word problems instead of just with a pair of numbers. Previously we talked about what factors are and what multiples are. That's really important that you keep those straight. Remember, factors are the numbers that you multiply to get another number, which means they go evenly into the number, which means we're breaking it up into smaller pieces. Multiples are the numbers that you get when you multiply a specific number times something else, and those will get larger. You're doing something over and over again, and that's going to help you when we are talking about word problems and the key words for finding the greatest common factor and least common multiple. So the first thing we're going to have to do is look at some basic words that help us to know in a word problem what we're looking for. Obviously, if it's talking about the largest, most, or maximum, those are all synonyms for greatest, so that's going to help you. Biggest as well. Other ones that are not quite as obvious are that we're talking about something into equal parts, we're dividing it into groups, or we're splitting it up. Now these also work, but the ones I've highlighted are the most common ones for greatest common factor. Moving on to least common multiple, these are synonyms for least, the smallest, and the minimum. But the most common ones, other than that, would be when you're doing something every so many days or something every so many hours. And when you're repeating something over and over and over, because when you're doing multiples, that's what you're doing. You're repeating a number times something else every time. That same number, like 2 times 3 is 6, and then you would do 2 times 4 is 8. You're doing the 2 over and over and over, which gives you the multiples. These also look similar, so you have to just kind of pay attention to the situation to know what you're trying to find. So it says we're going to carefully read the problems, then we are going to decide whether we're trying to find the GCF or the LCM, and work it out. Okay, so a choir director at your school wants to divide the choir into smaller groups. Do you see how it's saying dividing and groups? So we're going to divide the choir into smaller groups. There are 24 sopranos, 60 altos, and 36 tenors. Each group will have the same number of each type of voice. What is the greatest number of groups that can be formed? So those words that I highlighted, some of them are up here already. So that lets us know if we are breaking something into groups and we're looking for something that is the greatest number of groups, you're going to be looking for the, that's right, the GCF. Okay? The clues that we talked about for that are what we highlighted up there. One of them is where you divide into smaller groups. Another one is we have the same number. And there's your most obvious one there, the greatest number. Okay. When you're doing these on your own, what we just wrote or what you should be asking yourself to help you decide this. Okay. You don't need to write this every time, but for our notes, that's what we're going to be doing. Okay. So now we have to work out the solution. Well, what are the things that we have? We have 24 sopranos, 60 altos, and 36 tenors. So you use those numbers, and we find the GCF. Remember, we're going to use the bobsled. The biggest number that can go into them is what you would like to go for to begin with, but remember, if you can't, go with a smaller number that kind of pops out to you as a common factor for 24, 60, and 36. And I think of 6 on those. And then divide each. 6 into 24 goes 4 times. 6 into 60 is 10. 6 into 36 is 6. Can anything go into those numbers? Why, yes it can. And you're right, they're all even, so 2 goes into all of them. 2 into 4 is 2, 2 into 10 is 5, and 2 into 6 is 3. Now there's not a number other than 1 that can go into there. They don't have a common factor for us to divide out. So that means our GCF is on the left. We're going to multiply those two numbers. So 6 times 2 is 12. So that means we can have 12 groups. All right, let's look at the next question. It says Mary and Nancy work at a calculator producing factory. It's their job to inspect the calculators to make sure they are working before the calculators are shipped to the stores. If Mary inspects every 12th calculator and Nancy inspects every 9th calculator, which calculator will be the first that they both inspect? All right, so are they both doing the same thing over and over and over? Mary's inspecting every 12th. Nancy is inspecting every 9th. So Mary's going 12 calculators, and then that's the one she is looking at. Mary, on the other hand, is the 9 calculators combined, and then on the 9th one she's doing that one. The next 9 then is where she will be counting. And it says which calculator will be the first that they both inspect. If you look up here, both, and we're doing something repeatedly, that's going to tell us that we're looking for the GCF. The clues, again, are what we just said. Every, 12th or 9th calculator. Another keyword to tell us that we want the least common multiple, which is the smallest number that they have in common, and that would be the first. So the first time that it happens will be the least. Alright, so there are other clues in there as you read it. There are context clues that would tell you to find the GCF. I'm sorry, I said GCF. We are not finding the GCF. Yikes, guys. We are finding the LCM, the least common multiple. And that's why I went back and looked at those clues and said I circled the wrong answer. Well, every 12th calculator and every 9th calculator, it says which one will be the first they both look at. So we're going to divide into both. 3 goes into both. 3 into 12 is 4. 3 into 9 is 3. Can anything other than 1 go into 4 and 3? Nope. So the LCM is all of them. So we make the L. And we're going to multiply those 3 numbers. Okay. So the LCM is 3 times 4 is 12. And 12 times 3 is 36. So that says to us that the 36th calculator is the one that they will both look at. So do you see the difference in the two? Here we're breaking something apart into smaller pieces, factors. Here we're doing the same thing over and over again, so you're doing it multiple times, and that's a multiple. Alright, well, let's take a look at the next one. Okay, I'm going to let you pause the video. I want you to highlight, circle things that are important to help you to find the GCF or LCM, and then write your clues. Once you've done that, come back and we'll see how you did. Alright, welcome back. Hopefully you've highlighted what I did or something similar to it, and that you chose the GCF because we're splitting into groups with the most students in equal sizes. Now we're looking for the greatest number of students, so that's important. So let's work it out now. We have some seniors. We have 100 of those, and we have some juniors. We have 80 of those. We're going to find the GCF. Since they both end in 0, I'm going to start with 10. 10 goes into 100 10 times, and 10 into 80 is 8. Well, we can keep going because they're even, and you know that what number goes into both when they're even? That's right, a 2. 2 goes into 10 5 times, and 2 goes into 8 4 times. The only factor 5 and 4 have in common would be 1, so now we're ready to find the GCF, which is on the left. We're going to multiply 10 times 2, and we'll get 20. So 20 students is the most that we can have from each group on the floats. And that makes sense because we can break the seniors up into 5 groups of 20 and the juniors into 4 groups of 20. But again, they're only asking for the students and not how many groups. All right, I'm going to have you work on the next 2 by yourself. Come back and check them when you're done. Okay, let's take a look at number 4. I hope you chose the GCF because Ms. Stevens is looking for the greatest number of students she can have in the class and give them the same number of colored pencils and the same number of paper. So here, remember, think about what she's doing. Is she doing something over and over and over, or is she dividing something up? Since she is dividing the supplies up, we're looking for the factors, and we want the greatest number of students. So that's why I did the GCF, and that's how I got 30 students. The next one, if you need to pause the video and fix your work if you made a mistake, go ahead and do that. For the last one, this radio station is giving away a $100 bill to every 100th caller, and every 30th caller is going to get tickets to a concert. We want to know how many callers go through before someone can get both the $100 bill and the concert ticket. So the key words for the LCM here is we're doing every 30th caller and every 100th caller. So think about it. 30 calls, that person wins a ticket. 30 more calls, that person wins a ticket. 30 more calls, that person wins a ticket. Same thing here. 100 callers, $100. The next 100th caller, $100. So we're doing the same thing. We're repeating the same thing over and over and over. And that's some of the key words over here. Do you see? Every blank something. And we're doing something repeatedly. That lets you know that we're finding the LCM. All right. So when you find the LCM of 130, you get the 300th caller is going to win $100 and a concert ticket. All right, well, I hope this helped you to figure out how to look for keywords to let you know you're finding the GCF and the LCM. Again, the top part up here with these keywords is going to be very, very helpful. I hope you do well with this.